Hi, in this video, we're going to explore a new Cilium feature that is coming in Cilium 115, which lets you authenticate BGP sessions using MD5. Now, it's actually a feature that has been requested for quite a while. In the BGP realm, it's been available for, wow, about 25 years, right? So you can see the initial RFC 2385, which talks about how you can protect BGP sessions using the TCP MD5 signature option. It's now available using Cilium 115, and it's really simple to implement. And let's take a look in a demo. So for this video, I'm using one of our new labs, the Advanced BGP Features lab, where you can test a lot of different features we've seen in some of the videos. And I'll just going to show you how to set up BGP authentication using Cilium. And it's pretty simple. So first, you want to create a Kubernetes secret. And that's where you're going to store that kind of the actual password for your MD5 authentication. So let's run this command. As you can see, we are creating a secret, which is essentially based on the password, my secret password. We will need to configure that password on the other side of our peering session. Because what happens in MD5-based authentication is that we essentially apply the MD5 algorithm and create a hash, and we'll send it to our peer, and the peer will apply that same hash using their own password and verify that they match. And that's how we can essentially prevent spoofing and provide some more security to our BGP sessions. So now that we've created our password, let's go and take a look at our BGP peering policy. And we're going to now refer to this secret we just created. So the way it works in Cilium, the way we configure BGP is through something called a BGP peering policy, which is just a YAML manifest where you specify your BGP neighbor, your peer RS numbers, your timers, all your different BGP options, including now the name of the secret where you've defined your BGP password. So here, as you can see, we called it secret name, and that's what we're doing here, right? So let's just go ahead and apply this Cilium BGP peering policy. Here we go. Cool. Now, as mentioned, we've configured the Cilium, and now the Cilium session will actually go down because only one side of the session has gone down. So we can use a Cilium CLI to verify the peering relationships. And as you can see, the Cilium has gone into active mode, which means that it's trying to connect, but it can't, again, because the problem is the passwords don't match. One side has a password, the other side hasn't. So we're going to connect to our remote peer, which is using FRR, which is a free-range routing, which is a very popular open-source routing daemon. So we're going to go and configure that. First, T and router BGP 65,000, and we're going to go and add the password to my secret password. Just double check, show run, yeah. So, and we can, while we are connected to our FRR device, let's have a quick look. Summary. So you can see the session has just come back up and has been re-authenticated, and it's working great. And we can see, we've learned a route as well, so it's all working great. We've now re-established connectivity, and the peering session is back up, and we've authenticated on both sides of the session. Now, you can, if you're just curious, you can actually follow me as I use Wireshark to look in the actual TCP packet, right? If we want to see the hash and make sure that that session is authenticated. So again, we can, what we'll do is we're going to go into our Cilium agent and we're going to install TCP dump. Right? So it takes a little while. So I connect into the Cilium agent in the kubesystem namespace, and then I deploy TCP dump and Termshark. Right, Termshark is like the Linux version of Wireshark. And let's just run. First, we're just capturing the traffic for a few seconds, right? We're just capturing BGP traffic because that's over TCP port 179 and coming from our remote end here. Go. Now we're just going to take a quick look at that output. And in our BGP packet here, let's have a look. We're going to scroll down. So the BGP MD5 is essentially using the TCP MD5 option. So we have to look into the TCP header here and scroll down. And in TCP, in options here, you can see the TCP MD5 signature. Here we go. So you can see the MD5 digest here. So again, that's just to show you how the authentication happens. We, whenever the packet is sent, we create a digest based upon things like the source IP, ports, and using that password we created locally, we send that hash digest across to the remote side, which will then compare with their own digest. And if the digest don't match, the packet will be dropped. And that's how we just, again, ensure security of our BGP session. And it's all for today. Thank you very much for watching, and I will see you in the next one.